Chapter 1 is very simple introduction, and so I just have a few words concerning a few problems, and hopefully in later chapters I'll do some more. We begin by describing different types of data. Recall that the Titanic had a certain number of passengers, of which only 206 survived. What type of data is this? Is a parameter, and this parameter is with discrete numbers. Suppose you manufacture coins that have an infinite number of different weights that they can have. It's not a discrete weight, so we say this is continuous data. There are numbers that are very important, such as Social Security numbers, but yet have no mathematical values. On the other hand, there are numbers that have no mathematical values, but are helped to keep things in order. For instance, the rating of movies, 1 star, 2 stars, 3 stars, etc. The most important type of data is that which is random. For instance, if the Gallup poll surveyed a certain number of people and 39% had owned guns, then we can say that this is a representative number. The section on basic skills is very interesting because it also focuses on the misuse of statistics. For instance, supposing a statistics came out that showed that chocolate is healthy, but then we later learned that the survey was conducted by a candy manufacturer. Is this something that you would trust? One notable example was the Height Report on sex, where college girls volunteered their experiences. It later turned out that the girls sat around the dorm rooms and just made up a whole bunch of stories. In general, voluntary responses are not reliable. For instance, if people volunteer replies to Facebook or Twitter or things like that, those are not reliable. Responses must be random. This section also has a few math problems, which I hope will not be too difficult for anyone in engineering technology department. Let's say that a random survey of a certain number of students found that 8% had committed a crime and that 62% were drunk. I hope that we could easily calculate 8% of 1875 is 150, and then 62% of 150 is 93. There are many ways of designing statistical studies, none of which are easy, but there are different types. Supposing that you are doing a statistical quality control check of aspirin, where you have a huge number, but that you take a small sample. This is called an observational study. Imagine that we follow the effects of the attacks on 9/11 on the World Trade Center and that we're going to follow the people for 15 years. This is called a perspective study because we are looking into the future. Telephone poles can be accurate if they are generated in a random manner, such as by a computer. But what happens if the man programming the computer has his own bias? Then what? Once again, we are looking at a very large number of production, in this case M&Ms. Supposing we take every 10,000th M&M and measure it somehow, maybe the weight. At first, this could be an observational study, but more correctly, it's called systematic because we are taking every 10,000th M&M.